Good afternoon. I would like to thank the scientific committee for giving me the opportunity to present my work. All authors are employees at the Library of Medical Technologies. Nowadays, multiple catheter manometer systems are available to perform urodynamic studies, including air charge catheters. Pressure linearity, pressure offset, pressure drift, as well as frequency response, infusion rate are important characteristics to assess accuracy and precision for these systems. The aim of this study was to assess the performance of the TDOC 5-French air charge catheter for potential clinical suitability considering these 5 aspects utilizing laboratory-controlled settings. A total of 178 TDOC 5-French air charge catheters were used to assess pressure offset and linearity, frequency response, pressure drift, and infusion rate. Customized chambers were used to control and monitor pressures. Pressure offset and linearity, frequency response, and infusion rate tests were performed at room temperature. Pressure drift test was performed at 37 degrees Celsius. As you can see in figure A, we are showing a linearity of 0.99 with a standard deviation of 0.01 with an R-squared of 1. Offset was negative 0.18 plus minus 1.09% at 136 centimeters of water, and minus 1.65 plus or minus 0.65% at 272 centimeters of water. For frequency response, here in figure B, you can see the mean of the signal that was attenuated by 50% at 7.13 hertz, with a standard deviation of 0.88 hertz. The majority of the urodynamic events frequency are well below 7 hertz. Actually, the majority of the most relevant urodynamic events occur at 3 hertz. Pressure drift tests were done during 2 hours. And at the first hour, we observed a reduction in pressure of 0.48% with a standard deviation of 1.08%. At the second hour, we observed a mean of negative 0.36% with a standard deviation of 1.46%. The infusion rate mean between 20 and 70 milliliters per minute was 0.43% and varied to 1.54%. In summary, our results meet the ICS guidelines for UDS equipment requirements. Pressure linearity, pressure offset, and frequency response suggest that TDOC 5-French air charge catheter could be used for urodynamic studies. Because of the small sample size, more data is needed for the infusion rate and pressure drift. Additional tests are needed to quantify hysteresis and temperature response. Thank you.
Once you've done these 2 further technical tests, where does the next stage go? To clinical development, and what would you do?
Yeah, so all these tests were done pre-marketing the catheter, and we are doing concomitantly some pilot clinical tests to see if the results that we are finding on the bench test are being found similar during clinical studies.
And then do you then go to conventional water-filled catheters as a comparator?
For the clinical trials, we are not intending to compare, at least not for the 5-French catheter, because the majority of the population use the 5-French catheter children, and doing a comparison study in children will be a little bit more complicated.
All right. Thank you. Have you any questions?
Just a single point, your infusion rate test, I just really would like to emphasize the fact that the rate of infusion in the clinical setting your lovely results can not necessarily be used to easily translate into that rate in the clinical setting. And if I can, again, provide this question as a form of a plea, the use of reverse weight or infusion transducers, I think, is important, underemphasized, and I believe that some of your data support that observation. Thank you.
Thank you.
Thank you very much.